All right, here we're going to move on to our notes for section 7.4. And really today we're going to add or subtract. There is a reason that we learned how to multiply and divide first, because in reality that's way more simple when we're dealing with these rational functions. So let's go ahead and look at our learning targets for today. Today we're going to start by adding and subtracting those rational functions and the rules that we have to follow and the steps we have to remember. And then we're going to look at complex fractions and see what a complex fraction even is and how can I simplify it. So let's start with our adding and subtracting. So here's what we're going to need for today. We're going to walk through some examples together. Step one, again, I told you, we're going to factor everything. So we really do need to get good at factoring and review those steps if we're still struggling with that. So step one, factor everything. So just like if when we were dealing with fractions with only numbers, if the denominators are the same, add or subtract the numerator and keep the denominator. That's our common denominator, right? If the denominators are not the same, I have to write as equivalent fractions with the same denominator. So always remember we've got our parentheses around each numerator and denominator, and then we're going to simplify. So to avoid extra steps, right, this can be a long and funky process, so we want to avoid those extra steps if possible. To find my lowest common denominator, I take the product of the highest power of each factor that appears in the denominator of either polynomial. And we'll look at what that looks like. So we can, to find the common denominator, we could just multiply all our denominators together, but that actually adds quite a bit of work down the road. So let's look at some examples. And I'm going to walk through a couple of these with you, and then you are going to spend some time actually going through and doing them. Okay, so let's look at this first one. So I have 9 over x plus 1 minus 2x over x plus 1. The first thing I notice is the denominator is the same, so that becomes my common denominator. And then since I'm subtracting, I go ahead and I subtract my numerators. I notice now that there's nothing I can factor out of my numerator and nothing I can factor out of my denominator, so it's as simple as possible. So let's go ahead and look at a little bit more complex of an example. So here I have 3 over x plus 4 minus 1 over x plus 6. So these are not the same denominators. So to get the common denominator, I'm going to multiply them together. Okay, so my common denominator becomes x plus 4 times x plus 6, and I want to leave it like this. So then I go ahead and I multiply by the other piece. So here, this first term, you'll see that I'm multiplying by x plus 6 over x plus 6. And I multiply that because that is the piece that's missing in this denominator. Between my common denominator and this one, I'm missing the x plus 6, so I need to be able to get it there. But I also have to do that to the numerator, because this expression right here, this x plus 6 over x plus 6, is 1. So I can do that. Minus, I keep my original expression, but then the piece that's missing in this denominator that I need to multiply by is that x plus 4. That's the missing piece, so I multiply by x plus 4 over x plus 4. So I can go ahead and now multiply these two pieces individually, like don't multiply them together. So simplify this first expression. So I end up with 3 times that x plus 6. Leave your denominators factored like this. And then I multiply the second one as well. So now I'm going to go ahead and distribute this 3. Sometimes you'll actually need to multiply them all the way out, and I'm going to distribute this negative 1. So I end up with 3x plus 18 minus, and then in my parentheses, don't ever lose those parentheses, x plus 4. And this is all over, you'll notice my common denominator, which was that x plus 6 times x plus 4. Well, so now I see I have some distribution to do in the numerator. I want to get rid of this negative sign, so I distribute it to both terms in here in my parentheses. So I end up with 3x plus 18 minus x minus 4, and I just didn't write the denominator here. So then I can combine like terms. So 3x minus x gives me 2x. 18 minus 4 gives me 14. I could factor this. So I can actually factor this. I can factor out a 2, so it becomes x plus 7 over x plus 6 times x plus 4. Okay, but nothing can cancel out because I don't have an x plus 7 in my denominator. So really that is still as simple as it can be. So now here are a couple more that I want you to go ahead and try. The first step is to figure out, okay, what would the common denominator be? And then how can I get that to multiply out? So one thing you'll notice here is I have an x in both denominators, but my numbers are different. So what can I multiply to make simple and equivalent fractions in order to actually kind of get through them? Okay, so take a little time to work on these and come find me because I will have them worked out as well. So the second learning target that we were looking at today was complex fractions. And what a complex fraction is it's a fraction within a fraction. So I also have a fraction in my numerator or denominator or both. So here I'm asked to simplify. I've got this 5 over x plus 4 over this 1 plus x over 4 plus 2 over x. So you'll see I've got 3 different fractions all within one big fraction. So I have to kind of simplify. So the first step over here is I add my fractions that are in the denominator. Okay, so in order to do that, I have to find my common denominator, which I can see is going to be x times x plus 4, because those are the two denominators. I multiply this first term by x over x, because that's the term in the denominator that's missing. And I multiply the second one by x plus 4 over x plus 4, because that's the term in the denominator that's missing. So I end up with... I'm trying to find where I went. So here we go. This is my new numerator, my x plus 2 times x plus 4, which came from right here, over my common denominator, which was that x times x plus 4. And then I just simplified here. I distributed this 2 into both, so I end up with x plus 2x plus 8. So that can be simplified to 3x plus 8. So now I have just one fraction in the numerator and one fraction in the denominator. So the second step I do is I multiply by the reciprocal. So I leave the numerator alone, and I multiply, and I flip the reciprocal, and I flip the bottom fraction, and then I can multiply. Okay, and I follow my steps, my rules for multiplication. So I just multiply straight across the numerator, and I multiply across the denominator, which ends up down here. So I have 5x times the quantity x plus 4, and then I have x plus 4 times 3x plus 8. So now I can divide out any common factors. And remember, these are not terms, these are factors. We're not going to be killing kittens here. So I see I have an x plus 4 in both the numerator and the denominator, so I can go ahead and simplify to 5x over 3x plus 8. But finally, again, I have to figure out, okay, what would make my denominator 0? So I know that x cannot equal 0 and x cannot equal a negative 4. So again, I have to always come up with those things. Okay, so now today we've spent time adding and subtracting. We've also looked at complex fractions. So remember that we have to be able to simplify these complex fractions, so I'm only dealing with one rational expression and not fractions within fractions. So hopefully you spend a little time doing those practice in your notes. So now when you go and do your practice online, you're going to be just rock stars at it. So let me know whenever you get stuck or have questions on your homework, and we'll work through some of them together.